Okay, in this next video, we are going to look at angle measures and right triangle trig, where the initial angle that we are given is actually larger than 90 degrees. We've looked at right triangle trig problems that have looked like this before, where the acute angles within the triangle are smaller than 90. But we can actually have angle measures that exist that go from negative infinity to positive infinity. And the easiest way for me to signify this is an angle is just an amount of rotation. If you just spin around a bunch of times, okay, you're constantly increasing your angle measure, okay? So for example, like in basketball, if you did a 360 dunk, that would be one full revolution. If you spun around twice and then dunked it, that would be a 720, okay? That's measured in degrees, and we can actually utilize some terminology to help us understand that. So when we are dealing with angles in the coordinate plane, this is a vertex, and the positive x-axis is called the initial side. All right. And then wherever the angle goes to, all right, so there's going to be a certain amount of opening that happens with the angle, a certain amount of rotation. All right, so right now my pen is forming what we call the terminal side. All right, the terminal side is where the angle ends. So we have just dealt with angles that have ended in quadrant 1, so this is the measure of our angle. But we can have, again, I'll throw this in there for terminology purposes, the terminal side. But we can have an angle open more than 90 degrees, so you could have an angle measure, initial side here, maybe the terminal side is in quadrant 2. Okay, so this would be the measure of theta. All right. You could actually even go in the other direction. So maybe here theta is equivalent to 130 degrees, hypothetically. You could actually go the other direction as well. So if you rotate counterclockwise, the angle is said to be positive. But if you rotate clockwise, the angle is said to be negative. So if I went from here, rotated down to here to the terminal side, maybe this angle in this case would be like negative 120 degrees. All right. So angles can be positive or negative, and you can continue rotating around a whole bunch. So another example real quick to address all 4 quadrants, we could have a terminal side that exists here. And there's 2 ways we could get there. We could get there the negative way, so maybe in this case theta would be negative 30 degrees. Or we could go this positive way, which would be 330 degrees. All right, so that gives us an idea of where angles, the quadrants that angles can lie. So we can apply that with right triangle trig. All right, and this will get a little bit more complicated than what we've had in the past, but still overall I think will be very doable for us. So we're going to be given a diagram that looks like this, and you can see that we have a point that's on the terminal side. So here's theta. We want to find the sine and the cosecant of theta given this information. So the process for this is pretty simple. You're going to, I'm just going to redraw the figure. You don't necessarily have to, but I'm going to. So I have that point at negative 3, 6. What I'm going to do is draw a line to the vertex, or I'm sorry, draw a line, the vertex of the angle, which is at the origin. And then I'm going to drop a perpendicular to the x-axis to form a right triangle. So draw a line to the origin, draw a line to the x-axis straight down. Okay. The side lengths of that triangle, the x-coordinate is negative 3, so this value right here will be negative 3. And the y value is 6. All right? So that gives us 2 sides of the right triangle. We can find the third side, the hypotenuse, by using Pythagorean. So we'll do negative 3 squared plus 6 squared equals the hypotenuse squared. We're going to end up calling that r. You'll see why later down the road. So right now I'm just going to call it r squared. You can call it whatever you want. Right now, but that is what we will utilize later on down the road. So if we go ahead and solve that, that would be 9 plus 36, which is 45. So we'd have r squared equals 45. And if we take the square root, we will get 3 root 5. So based on that information, we can now find the sine and the cosecant. And here's the cool thing. This is kind of getting a little bit of ahead of ourselves, but what ends up happening here is this is theta. All right, the angle that we're actually going to look at, though, is what we call a reference angle. All right, so the reference angle is going to be the angle formed by the terminal side, and in this case, the negative x-axis. So our reference angle, the cool thing is, we can call that maybe something like just any different letter that you want. Sometimes we'll call it theta prime. That's probably the most common, but the bottom line is this angle will have equivalent trig ratios as this angle. All right, and I'll show an example of why that is in a second, but take my word for it now. So based off of this right here, 6 is the opposite, -3 is the adjacent, and 3√5 is your hypotenuse. So you have the ability to find the sine and the cosecant. Okay, so the sine of theta would equal the opposite, which is 6, over the hypotenuse, which is 3√5. And in this case, we can simplify that. 6 over 3 is 2, so that'll give us 2 over √5. And then we would need to multiply numerator and denominator by √5. So the result there, when that is simplified, would be 2√5 over 5. So that is our sine. Okay, now the cosecant, the easiest way to find that would be to take the reciprocal of this simplified version right here. Okay, you could do this one, but since we already simplified this down doing the 6 divided by 3, this would be the most direct way to get the cosecant. I would just take the reciprocal of 2 over √5, which would be √5 over 2. So there is our two answers for that one. All right, working through another example, same idea here. We want to find tangent and secant given this. Okay, so here we have theta. I'm going to put that point in the third quadrant. I'm going to draw a line to the origin, draw a line up in this case to the x-axis. So it's always from the point to the origin, from the point to the x-axis. That forms that right angle. The x-coordinate is -5. The y-coordinate is -3√3. So a little bit uglier here. And we're going to want to, once again, find that value of r. So we will do -5 squared, again, put that in parentheses, and then -3√3 squared equals r squared. So this will be 25 plus, here we got to be a little bit careful, that square will get applied to both pieces. So -3 squared is 9, okay? And the square root of 3 squared is 3, so 9 times 3 would be 27. Okay, so -3√3 squared. You can check on your calculator as I'm doing right now just to make sure I'm good to go. You should end up getting 27. And that'll give us r squared. 27 plus 25 is 52. And then take the square root of that. The square root of 52, largest perfect square that goes into 52, is 4. So that'll give us 2√13 for the radius or the hypotenuse. Okay, so from that point forward, we can now find tangent and secant. Again, in this case, the angle is theta, or in this case, theta went the other way, so I drew that the wrong way, but that's okay. So here's theta. This angle right here, all right, which has a vertex at the origin, is what we will label this in regards to opposite, adjacent, and hypotenuse. So you're always going to use what we call the reference angle, the angle between the terminal side and either the positive or negative x-axis. So based off of this angle right here, this is the opposite side, this is the adjacent, and this is the hypotenuse. Okay? So in that scenario, what we will do, finding tangent, opposite over adjacent, so the tangent of theta would equal -3√3 over -5, opposite over adjacent, so that would be 3√3 over 5. Okay? The secant of theta, secant we know is the reciprocal of cosine, so cosine is the adjacent over the hypotenuse. Okay, so it would be that over that. In this case, for the secant, we can go directly to hypotenuse over adjacent. So that would be 2√13 over the adjacent -5, and usually we'll just throw the negative out in front. Okay. One common question that we get is, will that sign ever vary? And the answer is no. The value of the hypotenuse in these types of problems will always be positive. Okay, and the reason for that is you're squaring those. So even if the legs are negative, the result of squaring a negative will be positive. So the x and y coordinates can be either positive or negative, but the hypotenuse, or what we'll eventually call the value of r, will always be positive.